Hi, welcome everyone. Thanks for joining in. I hope that you'll enjoy the presentation. I'm Igor Muchnik and I'm a Director of Cloud Platforms Practice of Blue Metal Architects. We're a consulting company. We're specializing in application modernization, cloud platforms, big data and analytics, mobility and information management. Throughout engagement with our customers, we've accumulated a wide range of expertise in solving complicated problems. And today I'm going to share with you a couple of tips that enable modernization of enterprise applications to fulfill the cloud requirements. The same tips can be applied to any type of the clients, including web, desktop, and mobile. Usually, during our demos and development conferences, we see and discuss architectures like this. But as you know, real life a little bit more involved and not ideal as this. Your data centers and applications in them a little bit more involved and complicated, and they may look something like this. You can have your requests processed by different farms, different stages. You have a lot of database and a lot of services involved. You may have long-running workflows that may require human interaction, human approvals. Think of workflows like processing shopping carts, image or music processing or enhancements, new customer registration, where you may have some sales or marketing person involved and it may require certain human approval. I hope you get the picture. So we want to make sure that when the user submits a request, his user experience continues to be fluent and flowing, and he can go ahead and continue doing other tasks while their request is being processed. But they want to be notified as soon as possible when it was in fact processed and complete, so they can continue with their workflow that was interrupted. And today I'm going to show just that. I'm going to show you how you can create a web client, but as I mentioned, you can use the same technique for a mobile or desktop client. But today we're going to use a web client as a demo. And we'll see how we can create a web client that provides such fluent user experience. The request will be submitted to our data center, and the data center will notify back the client when the process was in fact submitted. I'm going to use a simpler architecture like this, where I will simulate the larger environment that you've seen in the previous slide. So decouple our request processing, we are going to use queues. The queue will hold all the incoming requests, and the worker server farm will pick up those requests one by one and will process them. As soon as the request will be complete, we will see how we can notify clients back. When we're building cloud applications and web clients, one of the easiest way to maintain state is to create single page applications. This simplifies our web server farm drastically. It reduces dependency on the requirement of keeping the state somewhere across the servers. We can build stateless web servers and web services. That helps us to scale easily. When the web server fails, crashes, or disappears, or we add more web servers, we can process more incoming requests. If we'll need to store the client state on the web servers, it brings certain complexity into the fold. By building single-page applications, we move the state management responsibility from the web servers into the clients themselves. Tomorrow I have another session that talks about how you can improve your experience in building single-page applications. But today I'm going to build a very, very trivial web client, and I will use no-code to build single-page application in our web role. This is a coding only session. There will be almost no slides. There is no magic in the code, and I'm going to take you through all the set stages step by step so you can as well follow me along on your desktop. I've also uploaded the source code to my GitHub repository, so you are welcome to get the source there as well. So let's go ahead and start your Visual Studio. I'm going to use today Visual Studio 2012 Beta. Let's go ahead and create a new project from the Cloud Azure template. Let's pick up the MVC4 web role and the worker role. I'm going to create everything from scratch, as I mentioned, so I'm going to pick up an empty template. When we have everything set up and ready, let's go ahead and create our home controller in our web role. And make sure to pick up an empty MVC controller. And let's go ahead and create a default view. So today we're going to build a fake electronics store. So our customer is going to purchase items. So we're going to provide him with a form where he can provide us with information about the item that he's planning to purchase. This will be the field that will get the name of the item. And there will be a command button that when he presses it, we're going to submit request to our backend for purchase. Today I'm going to use Knockout to provide binding between our views and view models. Knockout is a great library for creating single-page applications. I'm going to bring out Knockout as well as jQuery into my project by using NuGet. Now I'm going to create a view model, which will be done inside JavaScript file. The view model will be initialized by jQuery as soon as the web page will be finally rendered. The item field in the view model, we will map it to the item input field on our HTML page. I'm going also to provide a default value. Let's hope that our customers will be buying cars through our store. As well, I'm building here an event handler that will be invoked by Knockout when the user will click the buy button. For the moment, I'm going just to log something into my web browser console. Let's go ahead and declare our bindings. I'm going to put a data bind attribute on my input field and use a value binding to bind it to the item field. And I'm going to put a data bind attribute on my button, and we'll use a click binding to bind to the buy item event. Let's go ahead and call Knockout and apply bindings. As well, do not forget to bring in the scripts into our HTML page. We will need jQuery, we will need knockout, and we will need our view model. If everything done properly, we should see working application. We will wait when Visual Studio deploys everything to this Azure debugging environment and the compute emulator. I'm opening console. We see that the value binding worked properly. We've received our default value inside our input field. And when I click on the buy button, I receive the printout in our console that reflects that the buy command was issued. So what you have so far is a very basic and trivial single page application. And you can see here in my diagram that we've created a view, which is represented by our HTML page, and a view model, which is represented by our JavaScript. Let's take it one step further. Let's take the command that user issued and send it through a web service to an Azure queue. Using the queues helps us to decouple our long-running processes from the clients. This ensures that we can return back to the client as soon as the command was submitted into the queue, and the client can continue operating while the background processes, in our case will be implemented by the worker roles, will take care of processing the user commands. So I'm going to create right now a web service, a very simple and trivial web service that will pick up the command from our single page application client and will create a message queue and will post a message into that queue with the command. So I'm going to create a web service by using a web API controller. And I'm going to create here a default post handler. That will receive our item, item to buy structure will contain information that user filled on the web form that will provide us with all the information necessary to create a purchase request. For the demo purposes, I'm going to create a public property of type string that will only contain a name of the item. Let's go back to our view model, and here inside our buy item event handler, I'm going to use a jQuery Ajax to send a post request to our web service with information about the item. So far so good. Let's see how this works. User fills in the forms, click a buy button, and we'll land in our web service with the information that the user wanted to purchase a car. So now it's time to create a connection to an Azure queue. I'm going to bring a small snippet that helps us do just that. So as you can see, I will be getting a queue connection string from the settings of the web role, and we'll be getting a reference to the by queue, and the next command will ensure us that the queue in fact exists. I'm going to add a connection string configuration setting in both web role and the worker role so we can use it. For the demo purposes, I'm going to use Windows Azure Store emulator. Now it's time to create a queue message. As the content of the message, I will use a JSON serialized data structure that will contain all the information necessary. You can use a binary information as a payload of the queue message, but for today's demo, I'm going to use JSON. As well, I'm going to use JSON.NET to create JSON objects. I'm going to create a field that will contain an item information. When this code will be finished, we'll have a message persisted in our Azure queue. Now I will go to my web role, now I will go to my worker role, and I will use a similar code snippet to connect to the same by queue, and I will extract message by message from the queue and will start processing it. The worker role wakes up once in a while and checks if there are any messages in the queue. You have to make sure not to starve the queues by pounding it as fast as possible. As well, you need to know the available rates that set up in your Azure accounts. In my case, I will be checking the queue every 2 seconds. I'm going to create a purchasing service. And I will have a process command. I'm using very trivial implementation here. This is only to simplify the demo. So be very careful and follow all the best development practices to build services. So here we go. Every time when the process command will be issued, we will connect to the queue and we will extract a next message available in the queue. Notice that getMessage has a time span parameter. When we extract the message from the queue, the message is not really deleted from the queue. It's merely hidden from other worker roles that will try to retrieve the message. This ensures that only one worker at a time will pick up the message for the processing. If you will not finish processing the message within the specified time span, the message will reappear back on the queue. So that happens to prevent us losing requests. When the worker role will fail or crash or something else will happen, Azure ensures that the message command will not disappear and will stay on the queue. The message variable will be null if there is nothing on the queue. So in this case, we just want to go back into waiting. But if we received something from the queue, we need to do our processing. So we will assume that in here we'll be running our long-running workflows. If everything is complete successfully, do not forget to delete the message from the queue. Let's go ahead and see now how everything operates. User clicks on a buy command, will land in our web service. Web service creates a message, posts it into the queue, and when the worker role wakes up and gets the message from the queue, it runs the long-running workflow. So far, so good. Let's go ahead and add processing to this message. First of all, we're going to retrieve the content of the message. And we want as well to deserialize it. I will use again JSON.NET. We need to bring JSON.NET into our worker role through NuGet. And then we can use it in our code. To simulate execution of our long-running workflow, I'm going just to modify an item description, and I will prepend it with a purchased or a processed message. So when we finish processing our purchasing request, now we want to notify the client that it in fact is complete. So how can we do that? We've received a message into our worker role, but now we want to send the reply back to our client. So for that, I need something that will help me to locate the client that submitted the request and send a message there. So today I'm going to use SignalR technology, which provides me with the PubHub scenarios. SignalR will help me to route messages through my web roles to the clients that submitted the request. But how can we do that? Our worker role doesn't know anything about the client itself. So to help mitigate this problem, I'm going to put in this purchasing request information about the web server that owns the connection to the client. So let's go ahead back to our shopping controller and put inside our message information about the instance of the server. I'm going to connect to the endpoint of my web role and extract information about its IP and the port. Let's go ahead and ensure that we have a main endpoint in fact available inside our settings. And we want to enable, for the demo purposes as well, this violates a lot of security issues, but for this demo it should be good enough. We're going to open a private port and a public port for Signal R, both of them available to send and receive messages. And I'm going to add information about this web role to the content of the message. So now we have information about this web server inside our worker role. But we still have nothing that will help us to connect to the client. So I'm going to bring in Signal R libraries into my web role via NuGet. As well, I'm going to bring Signal R client libraries into my worker role. We've seen on this diagram that we will need a hub to route the messages from our worker roles to our clients. So I'm going to create a hub, a Signal R hub, in our web role. Building Signal R hubs, it's as easy as just inheriting from a hub class. Every public method on this hub becomes an event listener. For us to receive message inside Signal R hub, we will need to create an instance of a Signal R client and use an address that we've received in the message to create a Signal R proxy, hub proxy, that will help us mitigate communication between the client and the hub. So this small snippet helps us to do just that. You can see here that first we create a hub connection to the address that we've received inside our message. We create a proxy to our messaging hub, and we will invoke a processed event. Let's just go ahead and make sure that they matched one to another. And we will send our message, our result, to that processed event handler. For the purposes of this demo, I also want to add information about a worker role instance that executed this request. So let's go ahead and do just that. So the instance variable will contain just a role instance ID, and we're going to add it to our processed event. So I'm going to add an instance variable that will receive this information inside our hub. Let's see now how all this works. If everything is done properly, we should receive message into our processed event handler inside our messaging hub. Let's go ahead and buy car. We've landed in our web service. Now we processed our message, and we've landed in our processed event handler in our messaging hub back in our web role. You can see here our message as well as an instance ID of a web role, of a worker role, sorry. So far so good. So now what's left to do is to route this message from the hub, from the SignalR hub that resides in our web role, to our single page client, and we want to receive it inside our view model. Let's go ahead and do just that. I'm going to bring into my web page, I'm going to bring SignalR libraries. Along with the SignalR library itself, I'm going to add a reference to SignalR/hubs magic URL. I'm saying magic here because in fact SignalR libraries inside our ASP.NET MVC will use the routing mechanism to subscribe to this, to processing of this URL, and will on the fly dynamically generate proxies for all the declared hubs in our web project. So now I can go into my view model and I can add SignalR JavaScript client that will subscribe to events from the messaging hub. Here you can see that I'm using $.connection.messaging hub. All this information becoming available for us due to the fact that we are bringing everything that was generated in this URL. I'm going to subscribe to item processed event that will come from our messaging hub, and I want to raise an item processed event inside my view model. So we need a reference to our view model. So let's go ahead and add one. So we'll do small refactoring here. And let's go ahead and add event handler that will receive two parameters: the message and the instance of the worker role that executed our request. I'm going to log it into the console. And we need to make sure to raise an item processed event inside our messaging hub. For this demo purposes, I'm going to use a client's helper that in fact raises event to all of the connected clients to this messaging hub. This is I'm doing only for demo purposes and to simplify this demonstration. So make sure to use this functionality only when you need it. So clients is a dynamic object that any method executed on this object will in fact raise an event. Let's go ahead and see if everything is working properly. I'm going to open a console here. We're going to send request to buy. We're landing inside our web service. Now we're landing inside our worker role. Here we've successfully created connection to the messaging hub, and we're going to invoke process message. Now we've landed into messaging hub back inside our web role, and we've successfully received our message inside our view model. So let's review what we just achieved. We've created a decoupled workflow that enables our single page clients, or in fact, as I mentioned, SignalR supports any type of the clients like web, desktop, mobile. This technology allows us to decouple the processing of our requests from the functionality of our client. The client can continue operating, the user can continue to be unblocked and do his usual tasks while we execute our long-running workflows. As soon as the workflow is complete, we can route the result back to the client that submitted this request. In real life, what I've showed you, it takes a little bit more work because the clients can reconnect to different web servers and we need to know how to locate them. But this is not as complicated as it sounds. But in this specific demo, we've seen how the message was successfully submitted into a queue through our web service, then picked up by worker role, was processed, and then routed through SignalR hub into our client. So from this moment on, I will go and will improve a little bit more our client-side user experience. So far so good. I'm now back inside our view model, inside web role, and instead of logging our message into the console, I want to notify user as soon as possible when the item was purchased and the workflow finished. For that, I'm going to use bubble notifications to pop up messages for the user when we've received item processed event. We are going today use Toaster JavaScript library to provide that functionality. Let's go ahead and bring Toaster via our NuGet feed. Okay, we will bring newly provided style sheets into our web page, as well as Toaster JavaScript library. And now I'm going to raise a Toaster bubble with the information that contains the message itself and an instance of the worker role that provided that purchasing. Let's go ahead and see how this looks like now on the client side. Okay, let's go ahead and buy car. We should see when everything was successfully processed. Here we go. We see Toaster bubble. So far so good. So the user received notification that the request was in fact processed. But what if he wasn't near the machine? What if he didn't see the bubble? What if he wants to review all those messages later? So I hope that you want to improve user functionality and user experience. So for that, I suggest that you create a page for the user that he can navigate, or in fact when we're building a single page app, so you will create a view that user can use to navigate and review all the messages that he received recently. Let's go ahead and do just that. I'm going to use an array inside my view model to accumulate those messages. In this case, I'm using a knockout observable array to accumulate those messages. I'm using observable array because that allows me to define inside my view a template that will be bound to this array and will automatically re-render every time when the information in this collection changes. Let's go ahead and bring such template into here. Here you can see that I've brought a table here that is binding a t-body content via for each binding to our observable array. This item template will be applied to each and every item inside our process message collection. Every time when our collection will be changed, Knockout will ensure to re-render the body of this table. So let's see how this works. Now, every time when we receive a message, we will add an item into our processed messages collection. Let's go ahead and add a message here. And a sender that will contain instance of the worker role. And let's see how this looks like. Here we go. You can see here that Knockout in fact rendered our collection, and you can see here the default value that I put here only for the demo purposes to show that the binding was successful. Let's go ahead and purchase a car. We should see bubble, and we see information was preserved in our view model. Let's go ahead and try buy a jet. And here we go. Our request was successfully purchased. Let's see what will happen if I will add more worker roles into the fold. I'm going into my configuration of the worker role, and here let's add 2 more roles. Here I'm bringing up our Azure Compute Emulator, and we should see 3 instances of the worker role running. Now I will buy car, and we should see that it was processed by worker role instance 0. We're going to buy a jet and a book and a table and a racing car. Now you can see here inside our notification view that those requests were processed by different worker roles at different points of time. So now you've seen how you can create a very responsive web applications, or in fact very responsive mobile clients or desktop clients that can submit long-running requests into our data centers and then continue working on different tasks while that request is processed off band. And as soon as the request is finished, we can notify clients, and clients can resume their workflows that required that information. So that concludes our demo today. This is all my contact information. You're welcome to send me an email. You can find me on Twitter, or you're welcome to participate and read my blog. I'm open for any types of communication, so feel free to contact me at any time. Thank you very much.